So this lesson is on experimental and theoretical probability. So you might be asking yourself, why might there be two types of probability? The difference between them is experimental probability is measured after an event has occurred, and theoretical probability is determined before. Now, the theoretical probability is just that, it's theoretical. After an event occurs, we can then calculate the experimental probability. So even though there might be a 98% chance of something happening, it could still not happen, because there is still a 2% chance of it not happening. And each event is an independent event, and each event has that 98.2% difference of happening, so the probability of happening. An experimental probability, though, if we're using that 98.2% example, if something fails once out of 10 tries, the experimental probability would be 10%, not the 2% failure rate that we would have theorized. Both probabilities are correct in that the experimental probability is what's actually occurred, but the theoretical probability is what we would expect to happen after many, many trials. That's theoretically what would happen. So let's look at how to measure and how to calculate both the experimental and theoretical probability. So experimental, the term experimental refers to something being carried out. So you will use experimental probability in research. You'll use it in social sciences and behavioral sciences, economics, medicine, and it's used to back up studies and research. The theoretical probability, though, is used a bit differently. That's used to determine the likelihood of something happening. So we can have a theoretical probability of a predictable kind of event. So if you're trying to, say, play a game at a casino, you can theoretically determine the probability of you winning or you losing just by fully analyzing the game itself. Example 1 has a coin flip that has flipped 24 times rather. And it says here the coin lands on heads 16 times and lands on tails 8 times. And we're asked, what's the experimental probability of the coin landing on heads? Well, in this case, even though we know theoretically a coin has two sides, so it has a 50% chance of landing on heads or tails if it's a fair coin, in this case, we had 16 heads and we had 8 tails. So there is a 16 out of 24 chance of landing on heads. And we can reduce that to 2 over 3. Your answer should always be written in lowest terms. We're going to keep that in a fraction. So the probability of heads is 2/3, 2 over 3. You usually wouldn't write a decimal unless it's a terminating decimal. And that is, it doesn't repeat forever. So we're gonna keep these written in fractions. Unless we can write them as terminating decimals, then we'll write them as decimals. So that's how you would determine an experimental probability. It's basically the number of successful trials divided by the total number of trials. So if it's a coin flip, the total number of flips is the number of trials. The successful trials would be, because we're measuring heads, the number of heads. Here's another example. We have 12 toys in a toy box. 6 of them are cars, 4 of them are dolls, and 2 of them are balls. If you were to grab a random toy from the toy box, what's the theoretical probability of grabbing a doll? So now we're moving from experimental to theoretical. And in this case, it's the number of successful outcomes divided by the total number of outcomes. So the number of dolls, because we're trying to find the probability of grabbing a doll, is 4. The total number of toys is 12. So our probability becomes 4 divided by 12, which would be 1 over 3, or 1/3. So the probability ranges between 0% and 100%. So when you're writing down your answers, you're never going to have a number that's greater than 1 or less than 0. So there won't be any negative numbers, and there won't be any improper fractions, or anytime you write a decimal, you're going to have a 0 in the ones digit, basically, unless it's at 100%. The last example looks at a more complicated theoretical question. This is one that requires the use of a probability tree. And we would use a probability tree anytime we have 2 or more events, and we're trying to determine the probability of something happening if multiple events occur. So here we have we're looking for the probability of catching different types of fish in a fish pond that has 15% carp and 85% bass. So carp and bass are 2 different types of fish. Typically when you're fishing, you catch a fish and then you release it back into the water. So this person's going to go fishing, and if he catches 2 fish and releases them back each time, what's the probability that he would catch 2 carp, 2 bass, or a carp and a bass? So to create our probability tree, you see here that we have 15% carp, 85% bass. That's basically how we would separate our first event. Then, because he's releasing the carp back, or the bass back into the water, the next event is again 15%, 85%, because he could catch the same fish twice. So in this case, we make the first part of our tree being 2 options between carp and bass. The second part of our tree, if he catches a carp, he can catch a carp or a bass again. And if he catches a bass, he can catch a carp or a bass as well. So it's basically the same decision, or the same event twice. But the reason why we're writing this out as a tree is because now we can use this to calculate our probabilities of each event. So the probability of a carp and then a carp, we would multiply the 2 probabilities. So 15% times 15%, and because we have 2 terminating decimals, we can end up with a terminating decimal. So that gives us 2.25%, or 0.0225. The probability of catching a carp and then a bass would be 15% times 85%, and that works out to 12.75%. Same thing for bass and a carp. It's just multiplied differently, 85% times 15%. And the probability of catching a bass and then a bass is 85% times itself. That gives us 72.25%. So now we'd have to state the probability of catching of each sort of situation, and whether he catches a carp and then a bass, or a bass and then a carp, that's still the probability of catching one of each. So we'd have to add those 2 together. So the probability of a carp and a bass would be the probability of a carp bass plus the probability of a bass then carp. So that's 12.75% plus 12.75%. That gives us 25.5%. And then we can just finally write our answers. 2.25% to catch the carp twice in a row, 25.5% to catch a carp and a bass, and 72.25% to catch a bass and a bass. So the support questions, for each of these, I'll just kind of go through them kind of a bit. I won't calculate for the first one, I'll just talk through it. So we have a die, a 10-sided die. So it's a die that has 10 sides numbered 1 to 10, and it's rolled 30 times. And the results of the rolls are listed below. We're asked to determine the experimental probability of rolling a 10. And in this case, we had 1 10 out of 30 rolls. The first number is a 10, and then after that we don't get a 10 another time. So that means we have a 1 in 30 chance of rolling a 10. That was our experimental probability for A. For B, it's the probability of rolling an 8 or a 9. So we'll have to add up all of our 8s and 9s. So just going through, I see there's 1 9 in the second row. There's a 9 and a 9 in the second last row. So now we're up to 3. And in the last row, we have a 9, an 8, and a 9. So there were 5 9s and 1 8. So altogether, there were 6 8s or 9s. And that would be 6 divided by 30. So 6 divided by 30, we can divide both of those by 2 to reduce our fraction. And the answer for 1B then would be 3 over 15. For C, I'll let you do that one where you count all the odd numbers. Same thing for D, a number less than 4, so all the 1s, 2s, and 3s. But for E, there's actually, I think there are 2 answers here. It says which die roll has an experimental probability that matches its theoretical probability. So the theoretical probability of rolling any one of these numbers would be 10%. It's a 10-sided die, so there is a 1 in 10 chance of there being a roll. So a 10% chance would be what we would get. So the theoretical then you basically have to look at each die roll and see if there's any that are more than what you would expect theoretically to roll. So, or any that are exactly what you expect theoretically. So if we had 30 die rolls and we expected 10% of them to be of each number, then 30 times 10% is 3. So the expected the expected outcome would be 3 of each number. So anytime you have a number that shows up 3 times, then that would be a probability. That would be one that matches the theoretical probability. Now I just want to go back quickly. I said 3 out of 15, and I said that was the lowest. Actually, you can go a bit further and get that to 1 out of 5. You can divide 6 by 6. You can divide 30 by 6, and that gives you 1 out of 5. Or if you want to write that as a terminating decimal, 0.2, 20% chance. So I will answer number 2. Let me just bring it up here. 2 and 3, I'm going to turn on my camera and answer these ones. So for 2, we have a bag that has a number of different coins in it, and we're asked what's the theoretical probability of grabbing each coin. So theoretical probability of grabbing a nickel, of grabbing a dime, of grabbing a quarter, of grabbing a loonie, and of grabbing a toonie. In each case, we have 18 coins. So the nickel would be 2 out of 18. Oops. The dimes would be 3 out of 18. Then we would have 7 out of 18 here, and the other 2 I'll let you do on your own. We'll have to write these in lowest terms, so this becomes 1 over 9. This would be 1 over 6, and this would be 7 over 18. That's basically what you're doing in this case. It's not very difficult to calculate this. You're just it's the number of successful events, and the successful event here would be grabbing one of the 2 nickels. Out of the total number of events, there are 18 possible coins to grab. So 1 out of 9 after we reduce that. Of course, 7 over 18, you can't reduce that. And I'll let you do loonie and toonie. That's not a very difficult question. But 3, we have a board game here where at some point in the game you're selecting 2 cards, and the cards could be red, blue, or green, but there are 2 red cards, and there is only 1 blue and 1 green card. So in the first situation here, I'm going to be creating my probability tree. I could get a red card, I could get a blue card, and I could get a green card. Now the probability of these are, there are 2 out of 4 for the red, which is a 50% chance. So I'm just going to write a 0.5 above that. A blue, there's 1 out of 4, so that's a 25% chance, and the green has a 25% chance as well. If I select one of the reds, I now have 3 options. I can select another red, I can select the blue card, or I can select the green card. And in this case, I now have, there were 4 cards here, now there are 3, so I have a 1/3 chance of each of these events. 1/3 red, 1/3 blue, 1/3 green. If I select the blue card, my options are either red or green, because there is no longer a blue card. And in this case, I have a 2/3 chance at getting the red, a 1/3 chance at getting the green. And if I get the green, I have a red or a blue. So this then gives me a 2/3 chance. 2/3 chance at getting the red, a 1/3 chance at getting the blue. So now I need to calculate the theoretical probability of each of these outcomes. So my outcomes then are red and red. I could also have red and blue. I could have red and green. I could have blue and red. I could have blue and green. I could have green and red, or I could have green and blue. So of all of these, I then need to determine the probability of each of them. And 1/3. So the probability of that is 0.5 times 1/3. The red and then blue is 0.5, 1/3. Red, green, 0.5, 1/3. In fact, every one of them, when I choose a red first, is 0.5, then 1/3. For the blue, it would be 25%, and then 2/3 if I'm selecting red. 25%, and then 1/3. 25% for green. 2/3 for red. 25% for green. And 1/3 for blue. So then I have to find out what each of these would be. This is 1/2 times 1/3, so this works out to 1/6, 1/6, 1/6. This would be 2/12, and 2/12 would reduce down to 1/6, of course. 25% and 1/3 would be 1/12. This would be 1/6, and this would be 1/12. So altogether, I should be able to add up to 1. So this would be 1/6, 2/6, 3/6, 4/6, 5/6, and a 1/12 and a 12th. That would be 1 altogether when I add that. Now the question says, what is the theoretical probability of a player choosing each outcome? And the outcomes, again, are 2 reds, a red and a blue, red and a green, blue and a red, blue and a green, green and a red, green and a blue. So we'll have to add, because if it's red and red, there is a 1/6 chance of that. Red and blue and red would be added together. So there's going to be a 1/6 plus 1/6. So in this case, a red blue plus a blue red would be the same as getting red and blue. So 1/6 plus 1/6 would be 2/6 or 1/3. Red green or green red would be the same, and that's going to be 1/3 because it would be adding those together. So red and green. And then we have a blue green or a green blue. We have 1/12 for each of those. Sorry, blue and green, 1/12 for each. So that's going to be 1/6 altogether. Sorry about that. Because you'd have to add those together. So 1/6, 1/6, 1/3, 1/3. You're either getting two red cards, a red and a blue card, a red and a green card, or a blue and a green card. And those are our different probabilities. So the lesson, or the assignment for this lesson, is listed here. The first task, you'll have to roll two 6-sided dice 30 times. Now, if you don't have two 6-sided dice, you can use the dice rolling website that I've provided for you, and that could be what you use to roll. What I want you to do is to show all of your rolls in the order in which you rolled them. And then I want you to rearrange that data. So first I want it in the order you rolled them, and then rearrange it from least to greatest. And then you can answer all these questions. So it's a little bit of an experiment to do, but make sure you do that. The second question is pretty straightforward. You're just calculating theoretical probability of each of these sort of situations of a student being selected from one of the 4 grades. In the third question, you're creating a probability tree. So if you have any problems with this work, just let me know, and I'll do what I can to help you out.